Welcome to Gemtrek. We're showing here a solution to basically an unrepairable motor that has been blown up.
We got this motor with the burnt out that had an explosion, so I've cut out all the cancerous part at the top here to a point. I'm now setting it up with the boring head. So we're just running it around to get that boring head centered up, and then I'm going to machine out a section out of the center here, and I'm going to make a ring that's going to drop in and weld into place, and then do a final machining on the outboard side of it. So yeah, that's the beginning of Bruce's solution. And this motor suffered an explosion, and it blew out all this part of the body. And this has an end shell that comes onto it and fits into this groove. And so what I need to do is to be able to close this gap up, get rid of the cancer, close this gap up, and I'm looking at two options. One of them may be to machine out this inner section down to here and make a ring and fit a ring in there, which will then allow the cover to close up. And the other option is to make a part ring and bring it around here, and then afterwards post welding machine it. And the third option is to get all the cancer out down to a point where I can build it up with a TIG weld ring around here. So I'm not quite sure which way I'm going as yet. First of all, I want to get the cancer out, and from there we can then decide. So once I've got rid of all this section here that's been badly burnt, hopefully I've got good material that I can connect to. Failing that, I can make a ring that'll go in there, which will be a little bit smaller than this section, as long as I've got the holes in there, and find a way of connecting that to here. So this will be ongoing. We're going to blast away at it. Give you a couple of seconds now of cutter action, and then we'll come back as the job continues. Only been down a lot, we'll go down some more. It would just be boring making this video on this process, so I'll continue on machining this out, and we'll get back to you with the next section. Okay, we're on part two. I'm manually taking this down. I'm just trying to ascertain where all the parts that have gone inboard. So we've got a single point where we can work on to give us a reference for the whole job. I'm just tickling it around here in the good part, and you can see now it's capturing even more on both ends here. And when the explosion came, it melted stuff inboard and outboard as well. So we're just going to run this down quickly to get that reference. As I showed the first one, we've cut out a fair bit on that on this side here. Now we're just tickling it up. want to get down to that height. So the first is you set the auto stop on the quill so it won't go further. It'll release. Got the luxury of a 4-axis DRO, so the K, which is the quill DRO scale, I've already preset it to 0, so I know where I'm going. I'm on 0. Okay, so we've cut round there. You can see that we're pretty close. The paint is still in there, pretty close to that area. We've daylighted out into here, and we've got a reference down the bottom here as well. So I'm going to take a breakaway and decide which way I want to go with this, whether only to put an internal ring in the hole in this section throughout, and then a secondary ring outboard of that, which will give us the face, the edge that we need on the outside for the end shield to marry up against. This is a bit high in this area. I'll be reversing the boring head later and trimming up this ridge here as well, and taking off whatever's the explosion has pushed up, so that we've got complete new facets machined out as our baseline references. There we go, continuing on, machining now, counter boring down. We're going to continue on with that until we machine out the wall thickness. I'll just come in a bit closer there. Yeah, we're going to machine that out till we get rid of all of that lip, and then from this ring which we just had cut, water jet cut, we're going to be making up an insert to go in here, which will then be welded in some parts and probably screw fastened in, and then we'll remachine the lip out to be able to connect, to make that connection piece. So running here at 0.08 of a millimetre per turn speed. No real problems with the machine at all. Because it's an interrupt cut, I don't want to take too much of the time. It won't take long. I'll get this in the lathe and I'll machine the outside diameter, and then rough machine the inside diameter. I want to leave as much thickness as I can, then I'll press it in, and then we'll weld it into place. This will make life much easier. I'll gain a centre piece out of that as well, and save me machining out of a larger and heavier, thicker drop that I had. It'll save me a lot of time. I've made up a ring. This ring will fit down into the casing, and the old end shell will fit on this point here, and then we'll tickle up whatever else we've got to do. So if we move across, we're at that point we're continuing on machining down. We're going to machine that till this will sit down in there, and then we're going to need to drill some holes to correspond with the cable entries, and we're going to need to fix it on the housing. That I'll just bring that down here. You'll be able to see. So there we have the end shell, the section of the end shell, and this is going to be on, as we said, welded on, and that will fit there into the end shell, and that'll clamp back up again. So this is we've basically made a new part to replace all of this area here. So we'll continue on and we'll come back with the next stage. We've got a busy place here in Bruce's workshop. The Jimbo is working on machining down this electrical motor housing, which we're going to be fitting this ring on instead of the blown out section. We've opted to go for a complete ring around the whole lot. The Jimbo's running at 240 RPM. That one's done. So we've got that one done for the next cut. Okay, now we're just cleaning up all of the cancer around the top edge. We've done the bore, so we're just working slowly around here with a big ball nose. And the big ball nose is doing the second cut. Just doing it quickly around here. Okay, so we've completed the machining of the bore. We've taken away the upper lip, which matches the end shield. I've made this insert, and that insert's going to go in here. I'm going to shrink that in a fraction. That's going to come down, and it'll marry up with the end of the machining that I did before. We have to leave a certain amount of internal diameter. There's got a nice thick ring here in order to allow room for when they do the wiring. The next thing I'm going to be doing over on this side, the cover, I'm not going to rebuild the cover. What I'm going to do is just bring it around and machine it flat so that we've got a flat surface here, and I'll make a new cover to suit that configuration. So I'll just do a little bit here with the die grinder, with the burrs, and clean it up. And I think what I'm going to do is, in a few places, I'm going to actually screw this into place. So yeah, I'll pick a couple of spots and I'll drill through and tap and put a couple of bolts in there. So I don't want to weld the whole thing. I will weld up part of this section, and of course we're going to have to close this edge of the box up as well, that part, and drill a hole through here to daylight those two cable entries, the one here and the one there, into the terminal box at the back. So they're going to be the next cab off the rank. So there we have it. We're moving on. Well, there we have it. We've finished machining and fitted in this ring that I made, and it's all nice and dandy. Sits in there beautifully. I'll be welding up part of this, and I'll be probably putting a couple of screws in on the other sides over here to hold it in place. I've got to machine this face flat. I'm not going to rehab this box, so I'll just make a cover to suit that. I'll leave that up to the rewinder guys. And then I'm going to have to drill a couple of portals through here where the cable entries are. So that'll be another job that I'll lay it over on the side, and I'll drill out those two entries. But otherwise, it's all good. Here's the end shield. Okay, we've advanced now. We've set the ring in place, locked it up. We've drilled and tapped some holes, and put some screws in here for retention, because I didn't want to weld all the way around, and I didn't see any necessity, because the end, all it's got to do is hold this plate in place, and the end shield will come up against it, and with the through bolts going all the way through, pulls that into tension, so there's no real load on this ring. So I've also started to pilot out these holes that the cables need to come through from the windings, and now it's just a matter of setting up. We're doing a little bit more, setting it up, and giving some welds along here, filling in this hole with a piece of plate. We'll put a piece of plate into there, clean up the surface here so that's flat, so then they can put the cover on or modify the cover to suit. So I'm not too happy about the integrity of this particular part here. This has just got the heavy flashing on it, electric flash explosion, so it looks very porous, so I don't think I'm going to be able to weld much onto this at all. This may have to be an epoxy job in the end, which is not the end of the world either. But what we're doing is we're saving up a very difficult to find motor, which is a high torque type, and this looks like to be the most viable repair, rather than have to wait months and months for a new motor. So there we go. We'll continuing on. Well, the deaf, half-blind, shaky TIG welder has managed to put this together. That was the last of what I had to do. So, of course, I had to put on my TIG welding helmet and get at it. As I suspected, I couldn't do any welding in this area. There was no integrity left in this part of the casting, so they're going to have to cobble together some little epoxy closure there, which I can't see as being an issue, or some plastic metal, something like that. But I'm quite confident that we've got a fix here. It's more welding than what I was going to do, but that was okay. The rest is tied together with these screws, and I just now do a little bit more cleaning up. Open up those holes a little bit more for the cable entries, and and deliver it. And then they can go ahead and rewind it and fit it and do everything else that needs to be done and put this thing back together again. Okay, we're on the last leg now. As I said, we've fitted the ring in, all that's done. Now we've got to get just where there's bubbled out, we're going to machine out the front here, the face, so that they've got a proper sealed surface. We're almost on it. We'll just cut through here and do another run around, and then that'll be it, ready for delivery.
So there we are. We've finished the job. Gemtrek is the house of the Trueline 8, which is a round column mill device for keeping the head steady. We also supply some other tools like our gear indicator and the Gemtrek caps, as you can see there, the logo.